Hello everyone, welcome to our channel Bank Coaching Center. Now in this video we are going to learn about linear programming. This is one of the important topic in CIIB examination and it covers around 5 to 6 marks. So linear programming is in module B of Advanced Bank Management subject. So in this session we are going to know about what is linear programming in detail, how it is useful in business decision makings, what are all the methods involved for finding the same, and the derivation of the formulas, and also some practice problems. So let us know what is linear programming. So linear programming, it is also called as linear optimization. So linear programming is a technique or method which is used to arrive a best outcome in a mathematical model. Like if a businessman wants to arrive a best business technique where he incurs less expenditure with huge profits. So linear programming is the technique which is used to arrive the best outcome by using a mathematical model. Okay, so linear programming is a process to determine the best outcome of a linear function. It is the best method to perform linear optimization by making few simple assumptions. So the linear function is also known as objective function. So objective function is nothing but our desired outcome. So in our real world, relationships can be extremely very complicated. So they are very complicated to assume. But by using linear programming, it can be easily depicted such relationships. Thus it makes us easy to analyze them. Okay, so linear programming is applicable only for the linear equations. So let us know what is a linear equation. An equation that is having the highest degree of 1 is known as linear equation. This means that no variable in the linear equation has a exponent more than 1. So here are some examples. The graph of a linear equation always forms a straight line. So some equations are given here. So the first equation is y is equal to 8x minus 9. It is a linear equation because the coefficient or exponent is 1. The power is 1. Okay. And the second equation, y is equal to x to the power of 2 minus 7. It means the power of x is 2. So this is a non-linear equation. The third one is y is equal to 3x minus 1. The powers of x and y are 1. So it is a linear equation. Y square minus x equal to 9. This is a non-linear equation because the power of y is 2. So it is clear that the equation which is having the power of 1 is treated as a linear equation. If it is more than 1, it is treated as a non-linear equation. So the applications of linear programming. The linear programming is mainly used in transportation, telecommunication and manufacturing units. Linear programming is a technique which is used to optimize a linear function or objective function. Consists of linear equality and inequality constraints. We obtain the best outcome by minimizing or maximizing the objective function as per our requirement. Linear programming always deals or applies only with the linear equation. Okay, we have seen already what is a linear equation. So let us see with an example how linear programming works out. So here is an example. So here suppose a milkman, he wants to deliver milk for 6 houses in a day, and the house of the milkman is located at the location A, and the houses, 6 houses, let it be U, V, W, X, Y, Z. They are in as shown in the figure. So the best outcome to serve all these houses with the within the less time and with the less consumption of fuel, he can make good profit. For example, this is already the directions which we have shown. This is already the final outcome. It is the solution. But let us assume that if the milkman starts at his house, first he deliver the milk to U, then Z, then W, then X, then V, then Y. So in this way means he will consume more time and more fuel. So as shown in the figure, first U, next V, next W, next Z, next Y, next X, then he goes to home. In this pattern, this is the best outcome where he can consume less time and less fuel, and he will get more profit. So likewise, this is only the example point of view. So likewise, in all the respective business entities, like the industries such as energy, telecommunications, transportation, manufacturing, everyone will be using linear programming method for their best outcomes. So let us know what are all the formulas and what are all the variables and what is the method used for arriving the linear programming. So a linear programming formula problem will consist of the following things. The first one is decision variable. The second one is an objective function, and the third one is constraints. So let us know in detail what are all these. Decision variables are nothing but the decision variables say X and Y decide the desired output of the linear programming problem and represent the final solution. And the objective function say Z is a linear function that needs to be optimized, either maximization or minimization. Maximization is for profit and minimization is for expenditure to get the solution. And constraints. The constraints are the restrictions that are imposed upon the decision variables to limit their value. Okay. So the decision variables must always be non-negative values, which is given by the non-negative restrictions. Okay. So this is the requirement for solving the linear programming. So the general formula of a linear programming problem is given below. So any situation we have to frame a linear equation like this. Objective function we represent here in our example as Z. Z is equal to AX plus BY, and the constraints will be CX plus DY, it is less than or equal to or greater than or equal to E, and FX plus GY less than or equal to or greater than or equal to H. But the requirement will be the restrictions, non-negative restrictions, means X should not be less than 0 and Y should not be less than 0. This is the non-negative restriction. So how to solve the linear programming problem? Let us see. So the most important part of solving linear programming problem is to first we have to formulate the problem by taking the data into a linear equation. Okay. So this is the step-by-step procedure to solve a linear programming problem. Okay. The step 1, we will identify the decision variables. Okay. So in our previous example, here the decision variables will be what we can say? The fuel and the distance and time. Okay, likewise. So here identify the decision variables, then we have to formulate the objective function. Okay, we have to put them, we have to frame them as an equation. Then we have to write down the constraints and ensure that the decision variables are always greater than 0. That is called non-negative restraint. Okay, this is also in examination they will ask the decision variables should always be dash. They can be 0 but they cannot be below the 0. Okay, they should be always positive numbers or can be equal to 0. And after framing this, then we have to solve the linear programming problem by using two methods. The first method is simplex method and the second method is graphical method. So let us see what is a simplex method. The linear programming by using simplex method. The simplex method in linear programming problem can be applied to problems with two or more decision making variables. Suppose let us take one example. Let us the objective function be z is equal to 40x1 plus 30x2, and our in our example, in this example we have to maximize. Okay, needs to be maximized and the constraints are given below. The constraints will be x1 plus x2 less than or equal to 12, 2x1 plus x2 less than or equal to 16, and always x1 and x2 decision making variables should be greater than or equal to 0. So the step 1 of simplex method is add another variable known as slack variable to convert the inequalities into equations. Also rewrite the objective function as equation. So what we are doing, this is the first equation we will put minus 40x1 minus 30x2 plus z is equal to 0. This second one we will write, for time being we will equate to 12. For that only we are adding y1. Okay, x1 plus x2 plus y1 is equal to 12. Likewise this also we will equate to 16. For that we will add one more slack variable, that is y2, means 2x1 plus x2 plus y2 is equal to 16. In the second step we have to make a simplex matrix by these equations. Same, we have to take the coefficient of this x1, x2, y1 and we have to make the simplex matrix. So write x1, x2, y1, y2 and z. Okay, so in the first equation, like x1, x2 plus y1 is equal to 12. So we have to put 1, 1, 1, no y2, so it is 0, no z, that is also 0, and that is equal to, we see here 12. We have to make it number 12. The same way the second equation 2, 1, 0, 1, 0, 16, and the third equation also minus 40, minus 30, no y1, y2, so 0, 0, z is there, z is 1 and the last number is 0. This is the step 2. We will construct a, initially we have to construct a simplex matrix. In the step 3 it is very important. So identify the column. Columns means the vertical things are columns and the horizontal things are rows. Okay, identify the column with the highest negative entry. Here highest negative entry, we are having two negative entries, one is minus 40 and one is minus 30. Here highest negative entry is minus 40, so the column 1 is taken as pivot column. Okay, pivot column, and so we have identified the pivot column. How? The highest negative number where we are having, that column is identified as pivot column. Then step 4, what we have to do, divide the entries in the rightmost column. This rightmost column 12, 16, 0. Okay. So divide these entries with the pivot column. Okay. So we exclude the bottom, and we have to exclude this bottommost row. Okay. So 12 divided by 1, that is 12, and 16 divided by 2, that is 8, and we have to exclude the bottommost row. And next, the row containing the smallest coefficient is identified to get the pivot row. So we are having two coefficients, one is 12 and one is 8. So which one is the lowest? 8 is the lowest. Okay. So 8 is in the row 2. So this row 2 is identified as the pivot row. Okay. So now you see the row 2 is identified as the pivot row, and column 1 is identified as the pivot column. The intersection of pivot row and pivot column is at number 2, and number 2 is taken as the pivot element. Okay. Then step number 5, with the help of the pivot element, perform pivoting using matrix properties to make all other entries in the pivot column 0. Means the pivot column is x1. Okay, 1, 2, minus 40. So we have to, what we have to do? We have to make all the pivot column elements to 0. How? Except the pivot element. So first we have to multiply. Okay, we have to multiply row 1 by 2, and we have to subtract. We have to subtract. Okay. Or else we can make, now we have done divide row 2 by 2. Then we will do the row 1 equal to row 1 minus row 2, so that the first element of the pivot column will be made 0. Okay. So what we are doing here, the row 2 is divided by 2. So our main target is this complete column except the pivot element we have to make 0. So we are dividing the row 2 divided by 2. So we will get this matrix 1, 1 by 2, 0, 1 by 2, 0. Okay. And 8. Okay. Then what we have to do? R1 minus R2 we have to do. So our first element has become 0. Then we will get these things. Next what we will do? Finally R3 is equal to R3 plus 40 R2. Okay. Then this element also becomes 0. Subsequently, this outcome you will get. Finally, what you have to do means check if any negative entries are there or not in the bottommost row. Okay. So there is a negative entry. Here it is minus 10. So if there is any negative entry, again what you have to do? You have to go to the step 3 and repeat the same process. If you repeat the same process, you will get this matrix. And now you have to check again if there is any negative entry in the bottommost row. So we have found that there is no negative entry in the bottommost row. So this is the final thing what we get. So writing down the row in the form of an equation. So that will be z is equal to 400 minus this 20y1 minus 20y2. Thus 400 is the highest value that z can achieve when both y1 and y2 are 0. Also when x1 is equal to 4 and x2 is equal to 8. Okay. When x1 is equal to 4 and x2 is equal to 8, we will get z as 400. Thus we have to give answer as x1 is equal to 4 and x2 equal to 8 are the optimal points and the solution to our linear programming problem. Okay. The next thing is, now we will see how linear programming problem will be solved by graphical method. Okay. If there are two decision variables in a linear programming problem, then the graphical method can be used to solve such a problem very easily. Suppose we have to maximize, again in this example also we are maximizing the z. Okay. So if we want to maximize this equation, the constraints, let us the constraints will be x plus 4y less than or equal to 24 and 3x plus y less than or equal to 21 and x plus y less than or equal to 9, and always x and y should be greater than or equal to 0. To solve this problem using the graphical method, the steps are given. Step 1, write all the inequality constraints in the form of equations. Okay. So x plus 4y equal to 24, 3x plus y equal to 21 and x plus y equal to 9. Plot these lines on the graph by identifying test points. Okay. So first we have to plot x plus 4y equal to 24. It will be passing through 0, 6 and 24, 0. Just in this equation you substitute x value as 0, then you will get the 0, 6. Similarly, you substitute y value as 0, you will get 24, 0. It is determined. In the similar way, you plot 3x plus y and equal to 21 and x plus y equal to 9. By making the value of x, you find out the value of y 0, 21 and you make the value of y equal to 0 and you equate, you will get x value as 7. Like that you have to make the graph. In the step 3, you have to identify the feasible region. Feasible region means you have to see all the three possibilities. Here these three possibilities should be achieved. See, we have to see the feasible region is the region, it is nothing but any point that lies on or below the line x plus 4y equal to 24 will satisfy x plus y less than or equal to 24. Similarly, a point that lies on 3x plus y equal to 21 should satisfy the second 3x plus y less than or equal to 21, and also point lying on x plus y equal to 9 should satisfy x plus y less than or equal to 9. The feasible region is shown in the figure. So if we draw our figure, this will be like this. This is the line 3x plus y equal to 21. This is the line x plus y equal to 9 and this is the line x plus 4y equal to 24. After solving all these linear equations, we will get the intersection points. Okay, so the intersection points are designated here 0, 6, 4, 5, 6, 3 and 7, 0. So the boundary of these points here in this area, the all conditions will be satisfied and this area is called feasible area. So the step number 5, substitute each corner point in the objective function. So what is our objective function? Our objective function is z is equal to 2x plus 5y. Okay, so in 2x plus 5y we have to substitute all the corner points. What are the corner points? 0, 0, this one 0, 6, 4, 5, 6, 3 and 7, 0. After substitution in the our objective function z is equal to 2x plus 5y, we will get these numbers. So in these numbers, which is the maximum number, that is our maximum output, that is the maximized output. And which point 4, 5, the decision making points are x equal to 4 and y equal to 5. In this decision making points 4, 5, we are getting the maximum value 33. In this way, we have to solve our linear programming problem by using graphical method. Okay, so this topic will be very important topic in CIIB examination, and you will be getting around 5 to 6 marks. And if anyone having any doubts in this topic, you kindly put in our comment box, and also please mail to us so that we can send this slide to you, and also we will send some more solved problems to you. And if any suggestions you want to make, please suggest. Thank you. And we request, please like our video, subscribe to our channel, and please support us so that we will release all other videos also, which are designed very simply for your CIIB examination. Thank you very much.